Okay, so here's what we did in class. I'm going to do it for you here. And make sure your homework, what you have to do is the even problems, 2 through 14. Okay. And when we have a constant in front, just remember, we got to pull it out. Pull that 3 out, and you can take the derivative. With respect to x. And just bring that negative out to the front so it doesn't look like it's 3 minus sign. It should be out in front anyway. Okay, now for this problem we use just the product rule. The chain rule is not even needed for this. And you choose which one you want to take the derivative first. I'll take the derivative of the first one first. So derivative of t is 1. We got cosine t plus the derivative of cosine, which is negative sine, times t. Okay, just clean it up a little, and you're left with this. So bring that negative over, and you're done. And now we can bring that t over to the front. Sorry. That's cosine t. I'm just bringing this t over here. And that's it for that one. Okay, and for this one we're going to use the combination of the constant and constant multiple rule and the chain rule. Okay, and again we can pull out that 6. And remember, only the x is being squared. And with respect to the inside function, okay, which means we're going to leave the x squared alone and take the derivative of just the cosine. And then multiply it times the derivative of the inside with respect to the inside, which is x itself. Okay, the derivative of cosine is negative sine. Leave that x squared alone, times the derivative of x squared, which is 2x. Now you can bring that negative out. And I'm going to go ahead and combine this, and also going to bring the x out there too. There you have it. Okay, here what you need to do is, let's rename this guy. We're going to move that 6 there. We're going to move that squared out where we like it, okay, so that we can recognize what's actually being squared is the whole thing. Okay. Bring that 6 out of there. And now we can start with our chain rule. We're going to take the derivative with respect to the inside. Okay. And the inside is cosine x squared. Cosine x squared. Okay. Times the derivative of the inside, which is the derivative of cosine x squared, but with respect to the inside, which is derivative of x squared. Okay. Times the derivative of the inside being x squared. Just keep taking all the derivatives of the insides until there's no more insides. Okay, when it's all said and done, you end up with the 6 out in front and let's go ahead and take the derivative of cosine x. We're going to bring that 2 out to the front. Okay. Leave the inside alone. Times. Okay. Cosine x, the derivative of cosine x squared. Leaving the x squared alone. The derivative of cosine is sine. Leaving that x squared alone. Times the derivative of x squared being 2x. Now we just clean it up. Okay, I'm going to bring this negative out in front, and I'm going to bring that out in front as well. And I'll probably just bring it all out to the 6 actually. Bring it out here. Okay. So we got 2 times 6, which is 12, and times another 2 is 24. So we have 24 with this x as well. Okay. Bring that negative out there. And we're all done. This one actually isn't needed. Let me erase it. I don't like it. So here, of course, we want to rename it so that we get rid of that square root. We don't like that there. And after this, it should be pretty easy. Okay, with respect to the inside, and the inside is cosine x. Times the derivative of the inside, which is the derivative of cosine x with respect to leaving that x alone, and we're done. Cleaning it up, well, actually taking the derivative of this, bring that 1/2 out. Oh, okay, sorry about that. Bring that 1/2 out, okay, out in front. That gives us 1/2 cosine of x. Don't forget to the negative 1/2 here. Okay, minus 1, 1/2 minus 1. And then times our negative sign here, because that's the derivative of cosine. Okay, now let's clean it up. We have 1/2. And this being to the negative exponent, we're going to have this guy on the bottom. And this remains on top. Okay, so I'm bringing this negative out. Okay. And I'm just going to make it one fraction. One little fraction. So we'll have negative sine of x to square root of cosine of x, because cosine of x to the 1/2 is the same thing as square root of cosine of x. So here, no big deal again. I mean, if you've seen something similar, you already know how to change it. So just take care of it. You got your tangent. We know how to change square root of 5x to 5x to the 1/2. Now keep in mind, the only thing being squared is the 5x here. Okay? 5x is being squared. So let's take it from there. Okay, with respect to the inside, which is the 5x to the 1/2. And if that's a little confusing, let's take, for example, sine of x. Okay, let's say x squared. Now remember, when we take the derivative of this, we take it, this part being the inside. Okay, that's the same thing here, except this whole thing is the inside. So that's where we get with respect to 5x to the 1/2. I hope that helps clear that up a little bit. And now times the derivative of the inside. Now, with respect to the inside, being 5x, okay, times the derivative of the inside, derivative of 5x with respect to x. Okay, let's start doing derivatives now. Now we can take derivative of tangent, which is secant squared. Something you have to memorize. Okay. Well, secant squared of 5x. If this helps, maybe that helps clear it up a little bit. Times the derivative of 5x to the 1/2, leaving the 1/2 alone, leaving the 5x alone. So bring that 1/2 to the front. Leave 5x alone to the negative 1/2. Okay. Now times the derivative of 5x, which is 5. Now I'm going to bring all the constants out to the front. Alright, let's do that. Okay. We got this portion on top, and because of the exponent, we have this one on the bottom. Now I'm just going to write the square root instead of to the 1/2, just to get it all done in that one step. And it also could be written like this. I'm also going to write the square root here as well. The 5's on the top, you can just leave it on top. And 2 root 5x. Okay, now remember, all this right here is one whole number. You cannot cancel this with this. This describes an angle. Okay? You cannot cancel those. There are two different types of numbers. And so here we have a constant here and we have a product here. So we'll use the constant multiple and the product rule as well. So bringing that 4 out, okay. We'll take the derivative of the first one first. So let's write it out that way. Secant 3x with respect to x, with respect to the inside, sorry, with respect to 3x, times the derivative of the inside. Okay. Let me clean that up there. Sorry about that. With respect to x. Okay, so that's the derivative of the first, okay, times the second, which is tangent 3x, plus the first, which is secant, times the derivative of the second. Okay, now use your formula chart to see if you can figure out from here. Okay, in about 3 seconds, I'm going to go ahead and post the answer. 3, 2, 1, and there you have it. Okay, so go ahead and do the evens 2 through 14, and it's due tomorrow when class starts.